Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, basically Expo explanation, I hope I have uploaded the video and you have watched it. So we're gonna talk about Urjana, basically a carbon capture and utilization. So it's not CCC, it's CCU, carbon capture and utilization. There is carbon capture and sequestration and this is carbon capture and utilization. So let's dive deep into it. So basically this company, the idea is they're going to capture CO2. A lot of companies are trying to do that. They're going to utilize it. That's the unique part. And they're going to, again, the plant they had in the expo, basically capture CO2 from industrial output. Basically you have some cement plant that is releasing CO2, concentrated CO2, like there is no tomorrow, coal power plant, things of that nature. So you're gonna collect it from that and then you're gonna convert it into raw calcium carbonate. They have some other options also, but raw calcium carbonate is the money maker, so to say. And the idea is reaction is chemistry based rather than energy based. There are a lot of other options, but they require a lot of physical energy, either by heat or grinding and things of this nature. So this one in terms of energy consumption is very little. While you do have to run liquid pumps and all that jazz, you're not gonna burn too much energy in order to do so. That's the good part. And the idea is they have catalyst, which is the special sauce, and it loops. So catalyst is not going to be consumed. That's the whole point of catalyst. And they have very low consumption of catalyst, meaning you do not have to worry about it. And generate profit from capture CO2. You have to understand that government can force a corporation to like, hey, you have to do this, but here's the deal, nobody will do it. And if they're forced to do it, they will shut down the plant. And it has happened, and government had to roll back, because while everybody's like, yeah, for environment and all that, they're like, bro, you will not pay extra for that. So fundamentally speaking, making profit from that carbon dioxide that you're capturing is necessary. Otherwise, this whole attempt will not be even worth trying. So question is why? Well, here's the deal. We keep releasing CO2 without end. The only time this whole graph had even a little bit of a wiggle was during pandemic era, where the CO2 release was like little bit. You could see it in the graph. But every time else from 1950, we have been capturing the data. This is from NOAA, Global Monitoring Laboratory. And they have been continuous data stream from that point. And be mindful, you can check from other agencies also. And this is collaborated, meaning we are very close to deep frying Earth's biosphere permanently. Once it's fried, it cannot be undone. Now, another aspect you have to understand, what sort of scale we are talking about. Scale we are talking about 320 parts per million was the earliest recording point when we started modern technology to analyze it. Yeah, we have crossed 450. That's a lot. And be mindful, nature does go through this sort of cycle expansion and contraction. However, that is done over geological time frame. Doing this quickly, that's the brutal part. It's almost like you can apply brakes in your car and you can safely slow down, or you can just like bam, get hit by a wall and slow down instantaneously. Instantaneously will kaput you. So that's the same problem. Earth is not that, oh, it can't handle like little bit of ppm rise. It can't handle it if it's happening in inside decades. And it's going up, like the linear graph is like, yo, it's like taking a rocket booster and going up. So we need a way to stop fresh CO2 from addition. Let that be very clear. CO2 itself is not the problem. It's the fresh CO2 that we are literally digging up from the past and dumping into the present. That's the problematic aspect. Everything else about the CO2, it's normal. It's part of its ecosystem, Earth's ecosystem. So it's not an issue. It's just that fresh CO2 that we are adding from the past, fossil fuel, that's the problematic part. And we have to capture, basically if this number keeps growing up, we will reach a point where we have to capture CO2 and sequester it. This idea of like, suppressing it and not emitting enough, yeah, that's not going to happen. Practically, realistically, again, real world data, yeah, that's meaningless at this point in time. If we do not capture it, we dead. So fundamentally, that's the physical hurdle. Like, what do you do? Second is you have to make sure it's profitable. Physics, engineering, economics. It has to make economical sense, or nobody will do it. Nobody cares. Like old people really do not care if like they lived a rich and healthy life. Who cares what happens to their children? So they do not care. They will burn this world down. So we have to make sure that the tools we are making, it's economically viable. It's logical to do. They will do it willingly. So question is how? The idea is direct source capture, as in exhaust from smokestacks will be captured directly. They're going to compress the hell out of it, and then they're going to feed it into reactor. Now this reactor has things, water and magical crystal. That catalyst and water will consume the CO2. that it will go to precipitation tank, basically where catalyst will dump it away. But again, to help it dump, it has to consume calcium source. How you get that calcium source, that's up to you. Water generally has calcium into it, including seawater. They do not require fresh water. That's the one good thing. So that's really useful. They do not consume fresh water, so you can have normal water. And again, most water have calcium into it. Not enough, but it is there. So if you just want to use water, you can do that, and you can get calcium source from that, or you can have your dedicated calcium source, and it's going to give you pure calcium carbonate. Now, calcium carbonate is a very desirable mineral, so to say. Like, people will willingly pay you. Again, you can check the market price of calcium carbonate. It's not nothing. It's like, it's a lot. And if you're getting this for without spending too much money, it is a profit generating scenario. So you can have a ROI, meaning more and more people will willingly do it. Okay. How? What are the toolkits? Well, the magic sauce is the special part. I did ask them, they did not tell me. That was the most boring part about the expo. Nobody was telling me the special sauce. And I'm like, dude, chemistry lab can see it. So basically that special sauce will not be consumed, and everything else is normal industrial machinery, meaning precipitation tank, pumps and reactors and all that. Those are common industrial part, meaning we were in Chemtech Expo. You could have just gone to hall number 3 and 4 and just bought everything. So that's the good part. It does not require any bespoke material. The spice is in the spice. It's in the catalyst. Everything else is normal, and catalyst is not consumed at all. So they can run this plant for years without consuming fresh catalyst. That's the good part. And everything works under standard pressure and temperature. It's not like a, supercritical CO2 where, while it has benefits, but the pressure it requires is bonkers. This does not require bonkers pressure. That's the good thing, meaning you can actually afford to, material wise, you can afford to do so. Normal industrial structure can easily handle it. Although there is one tiny issue, is that it has to be tailor-made, meaning if you are a coal power plant, they cannot just give you, this is coal power plant, take it and go. They have to figure out how much coal you are burning, what type of coal you are burning, what is the acidity and all that jazz. So it does require a bit of a bespoke attachment, and they are not designing it as a modular kit which you can just slot on. So the idea is they have to study your use case, then they have to work with you, only then they can give you the final cost and the product. So that is a bit difficult part, but not too what we call unmanageable. It's messy, but not unmanageable. So what can we expect in the future? Well, reality is capturing CO2 wise, but calcium carbonate, I have zero faith in that. And again, I'm too old and I've seen way too many BS without like carbon capture, and 100% of them have failed 100% of the time. And again, look into the satellite data. Not taking like my word or anyone, 100% failure. Like if there was a 100% failure, it was basically carbon dioxide capture, 100% failure. Most things released more carbon dioxide than they ever captured. Like somebody smoked something else, like what if we dumped a carbon dioxide in caverns underground? I'm like, have you heard of this thing known as geology? Have you heard of this thing known as earthquake? Even minor tremble, psh. Like again, you burned so much fuel just to do that, and all that CO2 was released anyway. It would have been better if you have not done that. So most carbon capture is just that BS, flat out, absolute BS, just money milking schemes. So it's not there. And again, even here, the carbon capture part, cool. Calcium carbonate part, not really that cool, because human, like they are very eager that you can sell calcium carbonate to pharmaceutical industry, and if you have high enough grade, they will pay handsomely for that. Cool, awesome. But here's the, what do you think happens to calcium carbonate when it goes to your body? Your body leaches calcium from it and dumps the CO2. You gonna release everything back. Basically, if you captured 1 million ton of CO2 and you sell this the material to pharmaceutical, which again, pharmaceutical does consume a lot of mineral, all of the CO2 you captured will be released again. Again, it will not happen overnight, it will happen slowly, but it will happen. Basically, the planet's CO2 parts per million will not change, it will keep growing up. So that's the problem part. Another aspect is cement plant. While at best, cement plants makes it like a, you take calcium, limestone, basically calcium carbonate, and then you calcify it and it becomes lime and CO2, capture the CO2, again make limestone. So it's almost like cycling it. So instead of basically limestone, you are cycling calcium source directly. It could help little bit of reduction, but it's not CO2 sequestration. To be fair, there are some people who are claiming that they are working on certain formulation that will make concrete hungry. It will absorb CO2. I had the luxury of talking to a world expert in this regard, LC3 Concrete. So Sasank Vishnoi is the expert on that, and I had that, and yeah, it's another BS. So again, I hope somebody cracks it, but as of now, 2026 January or February, I have not seen any stable, like, we capture it and it's gonna stay there for long term. So that's a big issue. So again, from human point of view, you can save some amount of CO2 emission by instead of trying to find a new fresh source of calcium carbonate, finding fresh source on site. Yeah, that will reduce some amount of CO2, but it's not sequestration. It's just like a efficiency gain. But again, not CO2 removal. It's not like if everybody started to do that, our CO2 problem will be solved. No, it won't be. And even if you're like, okay, what if we just keep the limestone? Like, don't consume it, just keep the limestone. Yeah, limestone is not stable enough in long term. We already have limestone deposits that are melting, not melting, dissolving. Why is that? Well, here's the deal. Have you heard of this thing known as acid rain? Same thing happens in your tummy, same thing is happening there. It's already releasing it, and it's a feedback loop. The more CO2 is released, the higher the acidic content, the higher the dissolve rate, more CO2 is released, the cycle continues. So fundamentally speaking, from a efficiency point of view, it could work. I could easily see that, hey, let's just say if 1 ton of calcium carbonate was consuming, let's say, half ton of fuel, and you reduce that half ton of fuel consumption to, let's just say, quarter ton fuel consumption, that's shut up, take money. That's better than nothing. Flat out, GG, awesome. But is it a CO2 solution? No. It's the same BS we have been hearing for, like, thousands of years at this point in time. Like, again, you have to understand that CO2, the only thing that we know for a fact that nature knows how to capture CO2, it's hydrocarbon, not CO2 raw, hydrocarbon. The only thing we can do, which has, like, does not have the penalty of surface area, does not have the penalty of energy source, it's seaweed biofuel. Make seaweed biofuel, convert it into crude, dump it back into underground. How do we know it will stay there? It was there unless we physically drilled it and took it out. It does not come out on earthquake. So that's the only thing that I've seen theoretically can sequester CO2 on geological time front. Failure to do so, it's all we are doing is delaying the death. So be mindful. There are a lot of people who are saying that if we start to touch 600 ppm, bad things will happen. So more R&D is needed on the stable part, so to say. Basically, we need a stable trap. We do not have it yet. And again, I have seen way too many of this, and all of it is BS. All of it. It's hilarious. It's almost like hydrogen projects. It's like, bro, we have been doing it from 1833. It does not work. Get over it. It's similar thing. Again, limestone dissolving. NASA has a whole documentation on it if you want to look into it. So again, it could be more of like, hey, creating a circular economy, reducing fresh carbon dioxide, GG. But carbon capture, and be mindful, even if you have it in nature, mild fire can release all of it. It does not even require like thousands of degrees Celsius. Like mild fire will release it. So it was very underwhelming. I'm happy with the CO2 capture part. I'm happy with the fact that making calcium carbonate, but as a CO2 capture, like saving humanity kind of technology, very lightweight, very, very, very lightweight. So this was my presentation on basically carbon capture and utilization. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.